Hey guys, I hope you're doing well. I just wanted to talk about the homework and just a couple things I was seeing. First of all, I hope you guys are doing well with this concept. I know you learned it last year, but still, it's been a while since you've seen it. I noticed that a lot of you guys on the homework use natural log, and I know that the key uses that. So I hope that you were really trying these problems on your own and not just copying the key. Especially like on a question like number 2, I wouldn't use natural log. You can, but I would just go about adding 12 to both sides. You get 5 to the 3x minus 2 equals 252. And then once you get here and you recognize you can't raise 252 to 5 to some power, that's when we can use this idea of writing in log form. Yeah, you could take the natural log of both sides, but I think it's easiest just to go straight into the log with a base of 5. Remember, going over the equals is going to be the exponent. And then we're going to put that 252 here. Now, from here, you can use your calculator since we are going to have to get a decimal approximation for this, as it says in the directions. So from here, I would just go to that on my calculator. So I would go to my log base. Okay, or I wouldn't. But I would go to, you could go to your log base, or if you even want to just do log 252, hit enter, and then divide that by log 5. It's the equivalent. Now, from there, think about this as a decimal approximation. It's approximately 3.436. And then you can just solve for, oops, I'm starting to solve for x in my head, by adding 2 to that answer you just got, and then taking that answer and dividing it by 3. So you get this value for x of approximately 1.812. So just something I noticed is that a lot of you guys were using natural log. Now, where would I use natural log on a question like 3? I think with something like 3, because it has that e in there, I would start off by taking the 5 and subtracting it. Then I would divide by the 3. And then from here, what am I getting? 2, and then that's 424. And then, because there's that e there, I would rewrite this in log form using natural log. The base is e, the exponent goes over here, and then that 24 goes here. Be careful, a lot of you didn't put parentheses around that 24, and as long as when you're typing in your calculator natural log 24 and either closing the parentheses or hitting enter, you'll be okay. But I saw some people just drop the natural log completely, and you want to be careful of that. Once you get that answer, you could subtract the 4, but then don't forget to divide by that negative in the front in order to get that answer of approximately 0.822. So hopefully that helps you with that one right there. For your factoring, so remember with this one, just think of this as like e to the x squared. So you can think of this in terms of u as being a u squared minus 4u plus 3. Remember where I talked about how e to the x equals u if you want to use a u substitution. And then hopefully you can see that e to the x is here and here. So we're just going to write u in place of that, and then factor it like normal. U minus 3, u minus 1. And then you're getting this solution of u equal to 3, u equal to 1, and then you can replace that with the e to the x. Be careful, that's not what x equals though. If you want to solve for x, write this in log form. I'm going to use natural log, and then remember the exponent goes on the other side of the equals, and then 3. So I get natural log 3 as my first answer on this, and you're going to get this x value of approximately 1.09. I'll bump that up to a 9. Now on this one, I mean, even not writing it in log form, think about it. E to what power equals 1? Anything to the 0 power equals 1. And that's not an extraneous solution. That works. Notice that if I sub that into the original problem, I'm going to get this e to the 2 times 0 power, which would be 1, right? Because e to the 0 power, minus 4 times e to the 0 power. Well, that's also 1, but I'm going to multiply by that negative 4. So I'm getting 1 minus 4 plus 3 And notice that that does in fact equal 0 when you sub in that original answer. Okay? And then the final one I wanted to discuss, because you guys, again, I don't know if you're good with this or you're just copying the key, but the one that I really wanted to talk about was this last one, number 8. This one I would expect to be challenges even if we were in school. So please note that this one is a more challenging problem, and even if I were teaching you this in class, we are practicing it, I know a lot of you would struggle with it. You can't get the same base on both sides. So right away, we're going to take the log of both sides. So I'm going to write the log, and then I'm going to put this all in parentheses just so you can see that. That's kind of, equals the log of 5 to the negative x plus 2. Now, the reason we take the log of both sides is because, actually, maybe I shouldn't put the parentheses, is because when you have the log and there is an argument that has a power, this whole power can move to the front, as can this whole power. It moves to the front. So once you have an argument that has a power on it, that power can move to the front if there's a log in front. So what I'm going to get is this negative 2x minus 1 times the log 8. And then I'm going to get on the other side the negative x plus 2 times the log 5. Now, from here, you want to get your x's on one side. The problem is, though, is that we have a product on each side, and then within that product, you see that there's a sum or difference. So we need to distribute the log 8. I'm going to get negative 2x log 8 minus log 8. So you see I'm distributing that. Now, on the other side, same thing. I am going to distribute the log 5 to each of these, and I'm going to get negative x log 5 plus 2 log 5. Now, if I want to solve this, I need to get the x's on one side. Notice this term has an x, as does this one. So what I could do is I can add this term to the other side to get it over to the left. So I get negative 2x log 8 plus x log 5. And then on the other side, I'm going to move this because this is just a constant. So I'm going to have on the right-hand side 2 log 5 plus log 8. Now, once you do this, you can factor out the x on both of these logs. So the one here, and you get negative 2 log 8 plus log 5. Now, from here, obviously, we have this in factored form. We could divide by this whole quantity right here. So we can divide by negative 2 log 8 plus log 5. And then same thing over here. Now, a lot of you, and I think it's because the key did, use the properties to rewrite these logs, but it's really not necessary, and maybe that's what caused you some confusion, is that if you're just solving for x and you're allowed to have a decimal answer, there's no reason to use the properties to condense this. I mean, sure, you can bring this 2 back. You can then take this plus sign and make a product of the 5 squared, or 25 times 8, but it's not necessary because you don't have to keep this as an exact answer. You're allowed to write it as a decimal. So just do in your calculator 2 log 5 plus log 8 and get an answer. And then be careful with the denominator. I would hit divide this, but then use another set of parentheses to do the negative 2 log 8, close that set, plus log 5, close that set, and then close the entire denominator as well. And you should get this answer of approximately negative 2.078. So let me know if you have any other questions. Don't forget there is a key posted. And honestly, guys, this problem was here. This was not created just for what we're going through. This is a problem we've used for many, many years. So I just was, as I was doing some of these problems and looking it over, I forgot about this problem being there. So too soon. Anyway, hope you're doing well.